Alright, I want to find the absolute extrema. So the first thing would probably find the derivative set equal to 0. So to set the derivative of this, h prime x, derive the top, which would be 1, leave the bottom, minus, leave the top, derive the bottom, over x minus 2 squared. From there, just simplify the top. Well, it looks like we got, want this x cancel with the x, leaving simply with negative 2 over x minus 2 squared. So that's the top. So that's the derivative. And then what we do is you set the derivative equal to 0. So you set the top and bottom equal to 0. So the top doesn't matter to set negative 2 equal to 0. It doesn't do anything. Set the bottom equal to 0. And when we do that, you square root both sides to get rid of the square. And you get x minus 2 equals plus or minus 0, which doesn't matter. And so that means x equals 2, which 2 is not in my interval, so I can exclude it. It is a critical number, but it's not in the interval. So really all we got to check for this problem is check 3 and 5. And see which one's the highest, which one's the lowest, because there's no other points between there that get higher or lower than them. So basically, we need to do h of 3, which should be 3 over 3 minus 2, which is 3. Is that right? So you got 3, 3 is one coordinate. And your other coordinate would be h of 5, which is 5 over 5 minus 2, which would be 5 over 3. So 5 comma 5 over 3. And just look at those two values and think which is the highest, which is the lowest. You just look at the y values. This is higher than 1 2/3. So this is your absolute max. This is your absolute min. Alright? Now, if you had a different interval that included 2, let's say it went from 1 to 5, you'd have to check 1, 5, and this 2. Okay? But since the 2 is not in the interval, you exclude it. But you still have to check for it in case it was in the interval. Alright, let's sketch these two graphs. First of all, if I want to sketch 2 minus x squared, what you have to realize is this is a graph of a parabola upside down starting at 2. Okay? And it would look something like this. Alright? And it's just going to be upside down parabola. And this other one, which, actually before we do that, before we sketch it, let's find the endpoints. Okay? Let's just find the endpoints. Because if we're doing absolute extrema, don't we have to plug in the 1? So let's find f of 1. If we're finding f of 1, don't you plug it into this function right here? So it's 2 minus 1 squared, which is 1. So at 1, that's your value right there. So I know that's a point. Okay. Now, if I want to do f of 3, isn't that where they meet? See right there? F of 3. Now, f of 3, which equation would you plug it into, though? Isn't this the or equal to? Isn't this the or equal to? So isn't this the one part of the equation? So you go 2 minus 3 times 3, which gives us the interval goes from 1 to 3 and 3 to 5. They meet at x equals 3. So that would be negative 7. So at 3, we're going to be down 1, 2, 3, 4, 5, 6, 7. So if you think about this graph, it kind of looks like this. But from here, isn't it going down like that? And then let's find f of 5, which is the other endpoint, which would be 2 minus 3 times 5. Be 15, so that'd be negative 12. So at 5, we'll be down way down here at negative 12. And isn't this a straight line? So that would just be a straight line like this. Thank you. Negative 13. Thank you for the correction. It would be negative 13. It would still be down here somewhere. I may not be completely accurate, but it would be going through 2 right here. But you have two graphs. You have this green line, which is nice and pretty straight. Yeah, right. You have a nice straight, ugly line I drew. But there's your straight line, and here's your parabola. And you're taking this piece of the parabola and that piece of the straight line, the green and the blue. Now looking at these, did they actually hit? Well, I assume they hit, but let's double check. I just assume they hit there. Let's double check. If you actually plugged 3 into this equation, what do you get? If you get f of 3 when you plug it in here, isn't that 9? 2 minus 9, is that negative 7? So you have to double check that these two graphs hit. And they do. Okay? If you plug f of 3, again, you could have also found f of 3 and done 2 minus 3 squared and also realize it's negative 7. Those two need to match. Okay? Otherwise there would be a split in your graph. But this one does connect. So, looking at this graph, is it pretty obvious, the max and min? Yeah. So we have this point right here, looks like the absolute max, which would be 1, 1. And the other one would be 5, negative 13 would be your absolute min. Now, here's a quick question. Does the slope exist right there? No, it's a jagged point. That would be where, that's a critical number. Do you follow me? That actually is a critical number. The slope does not exist there because it's a jagged, non-smooth point. But is that highest or lowest? No. So do you understand, on a piecewise, you always need to check the interval in between. This piece could have actually been a max or min where they connected, because it actually is a critical number because the slope does not exist there. It is a jagged edge.